Greetings, and a very warm welcome to you. You have arrived at Science for Sleep. I am genuinely so delighted that your path has led you precisely here, to this sanctuary, at this moment tonight. Perhaps you are just beginning to settle in for your evening, allowing the day to gently fade away. Maybe you are curling up comfortably, perhaps with a wonderfully warm and soothing drink in your hands. Or, it is possible, you are simply searching for a brief, precious moment of quiet, contemplative wonder within the business of your day. Whatever the reason, you have found our gentle, shared corner of this vast universe. This is a special place where the hard lines of physics softly blend into the deep questions of philosophy. A realm where concepts that seem utterly impossible begin to feel wonderfully and perfectly inevitable. It is a space where the most profound and deepest mysteries of existence are allowed to unfold, slowly, at a pace that permits your mind to genuinely and fully absorb their intricate beauty. This evening, we are preparing to embark on a truly fascinating journey. We are traveling to a place that already exists all around you, a place that resides deep within you, and yet it is a place that functions according to a set of rules so profoundly strange, so bewildering, they would make the fantastic tales of Alice's Wonderland seem perfectly logical and entirely ordinary by comparison. We are setting forth, venturing deep into the quantum realm. You can think of this as a fundamental dimension of reality, a substrate of existence where the familiar rules of our world simply dissolve. It is a place where tiny, infinitesimal particles possess the astonishing ability to be in two distinct places at the very same time. It is a dimension where the simple act of observation, just looking at something, fundamentally alters the reality of that thing itself. Furthermore, it is a domain where the very process of taking a measurement does not merely record what is there, but actively participates in creating the very world that we perceive and see. But here is the concept, the truly revolutionary idea that will genuinely astound you. Recent, groundbreaking discoveries have begun to reveal, with increasing clarity, that this quantum realm is not just some esoteric, abstract playground reserved for the complex equations of theoretical physicists. It is not confined to chalkboards and laboratories. No, the quantum realm is dynamically and actively shaping your personal reality at this very moment, right now, in ways that would have been dismissed as pure, unadulterated magic only a few short decades ago. Now, just before we truly begin this fascinating exploration together, I would genuinely love to know where in this wide, wonderful world you are listening from tonight. What location are you in, and what time is it currently in your specific, unique corner of existence? It does not matter if it happens to be a deeply quiet midnight in Melbourne, Australia, or perhaps a wonderfully peaceful afternoon unfolding in Minnesota, in the United States. Wherever you are, whatever time it is, please know that you are incredibly welcome here, in this space. And as we journey, if you find that these gentle travels through the cosmos are soothing to your mind, if they bring you a sense of peace, please do consider giving this video a like and perhaps subscribing to the Sleepy Physicist. This simple act genuinely helps other people, just like you, to discover this tranquil and safe space, this haven where science is allowed to become a form of beautiful, flowing poetry. Now, I feel I should also mention that while this evening's exploration is meticulously designed to be both deeply fascinating and profoundly relaxing, the subject of quantum mechanics possesses a very peculiar, almost mischievous way of being so utterly intriguing, so captivating, that it might just tempt you to stay awake a little bit longer than you had originally planned. If that should happen, please do not worry. At least you will eventually, peacefully drift off to sleep with your mind absolutely brimming, filled to capacity with the most beautiful, the most elegant, and the most profound mysteries that our vast universe has to offer. So right now, I invite you to take a slow, deep breath. Feel the air fill your lungs, and as you exhale, just let your shoulders relax, releasing any tension they might be holding. Allow yourself to settle in and prepare to discover what is actually waiting for us inside the quantum realm. I say this because what we are about to explore together this evening is not just abstract theory anymore. It is no longer confined to speculation. It is, in fact, the hidden, fundamental foundation of reality itself. To begin, picture, if you are able, holding a simple coin in the palm of your hand. In our familiar, everyday world, the classical world, that coin has only two definite states. It is either showing heads or it is showing tails. There is no other option. But now I want you to imagine a different kind of realm. A realm where that very same coin could exist as both heads and tails, completely and simultaneously. Imagine it spinning in an ethereal state of pure, perfect possibility, holding both outcomes in potential until the very instant, the precise moment that you choose to look at it, to measure it. This concept, this image, is not a flight of fantasy. It is not make-believe. This, in essence, is the quantum realm. It is a fundamental dimension of existence that perpetually surrounds us, always present, operating silently just beneath the fragile threshold of our ordinary, everyday perception. The quantum realm is not some far-off, distant place. It is not a destination you might one day visit in a compelling science fiction story, traveling through space and time. No, the truth is, it is right here, right now. It is present in the countless swirling atoms that coalesce to make up your physical body. It is present in the very particles of light, the photons that are streaming through your window at this moment. It is present in the intricate, microscopic electrical signals that are right now dancing and firing through the neural pathways of your brain, allowing you to process and understand these very words as I speak them. Every single breath you take, drawing air into your lungs, is a quantum event. Every single heartbeat that pulses within your chest relies on quantum processes. Every thought, every fleeting idea that crosses your mind is intimately and inextricably connected to these deep quantum processes. Processes that, if we were to judge them only by the familiar, rigid rules of our larger, classical world, would seem utterly and completely impossible. But what, precisely, is this mysterious realm? What defines it? At its most fundamental, most basic level, the quantum realm can be understood as the domain of the extremely incomprehensibly small. It is the world of subatomic particles. And down here, in this world, things behave strangely. Particles begin to act more like ethereal waves, spreading out in fields of possibility. It is a place where the concept of absolute certainty simply dissolves, giving way entirely to the mathematics of probability and chance. It is a realm, as we have touched upon, where the very act of observing something becomes, in itself, an act of creation. This quantum world is governed by a set of principles so profoundly counterintuitive, so deeply baffling to our everyday logic, that even the great Albert Einstein himself truly struggled to accept them. He was famously deeply unsettled by its implications, famously declaring in frustration that, God doesn't play dice with the universe. It is a beautiful, poetic statement. And yet, how beautifully, how profoundly wrong he turned out to be. In January of 2025, a team of physicists working at Brown University made a remarkable discovery, a finding that sent immediate ripples of genuine excitement and curiosity throughout the entire global scientific community. What they found, what they observed, was something that, according to all our established theories, simply should not exist. Based on our traditional, long-held understanding of quantum mechanics, they found particles, which they have called fractional excitons, that absolutely refused to fit neatly into the tidy, organized categories that we scientists have been using to organize the quantum world for many decades. These newly found particles did not behave like the bosons we expected, nor did they behave like the fermions we expected. Instead, they astonishingly showed profound characteristics of both, all at once. It was as if nature itself had looked at our human-created rulebook, decided it was far too restrictive, far too simple, and then proceeded to write entirely new, complex chapters that we had never even imagined were possible. To grasp this, imagine for a moment trying to categorize every single person you know as either introverted or extroverted. You have only those two boxes. But then, you meet someone who is, somehow, inexplicably both, simultaneously. A person who seems to change their fundamental nature based on the situation they are in, yet all the while, they remain perfectly and consistently themselves. This is precisely what these fractional excitons represent within the quantum realm. They are a powerful, tangible reminder that nature's inherent creativity, its sheer ingenuity, extends infinitely far beyond the limits of our current human understanding. But to genuinely, truly appreciate the full significance of discoveries such as these, we first need to take a step back. We must pause and explore the foundational, fundamental principles that govern this hidden, underlying dimension of our reality. The quantum realm, as we currently understand it, operates on what we can call 4 pillars of strangeness. These are 4 core concepts that, when you understand them together, in concert, reveal a universe that is profoundly more mysterious, more intricate, and far more deeply interconnected than our limited physical senses could ever, on their own, suggest to us. The very first pillar is a concept known as wave-particle duality. This is, quite possibly, the most mind-bending, reality-questioning concept in all of physics. In our normal, everyday experience, things are distinct. They are either waves or they are particles. Think of ocean waves, for example. They spread out, they ripple across vast distances, skillfully carrying energy without actually carrying matter along with them. On the other hand, things like baseballs are solid, tangible objects. They are particles. They follow clear, predictable paths through space. But down in the quantum realm, this clear distinction vanishes. Every single particle of matter, an electron, a proton, and every single photon of light exhibits both wave characteristics and particle characteristics. Which one it shows us depends entirely on how we, the observers, choose to measure or observe them. Physicists at MIT, Massachusetts Institute of Technology, recently performed what they affectionately call the most elegant version of the world-famous double-slit experiment. They stripped this classic experiment down to its barest quantum essentials. And in doing so, they confirmed something that, even today, still makes seasoned physicists pause in sheer wonder. Light, and indeed all matter, truly exists as both a wave and a particle. However, we can never, ever see both of those natures simultaneously in our observation. It is as if reality itself is engaging us in an elaborate, cosmic game of hide-and-seek. It reveals only one face to us at any given time, the particle face or the wave face, while always keeping its true, dual nature forever hidden, just tantalizingly beyond our complete grasp. Think of it in this way. Imagine you have a very close friend who appears to be a completely different person depending on whether you encounter them at their workplace or at their home. When they are at work, they are perhaps incredibly professional, highly focused, and very methodical. But when you see them at home, they are wonderfully creative, completely spontaneous, and free-flowing. You might, for a moment, think you actually know two entirely different people. But of course, it is the very same person. They are simply expressing different, valid aspects of their nature, depending entirely on the context of your interaction with them. This is precisely how particles behave in the quantum realm. They show us their wave nature, or they show us their particle nature, but they never, ever show us both together at the same time. Scientists at the Stevens Institute of Technology have even developed sophisticated mathematical frameworks that can now actually quantify the waveness and the particleness of quantum objects. They are creating beautifully elegant curves that meticulously map the precise, delicate relationship between these two dual aspects of reality. And this is not just a matter of academic curiosity. It is not just for theory. Understanding, and one day hopefully controlling, this wave-particle duality is actively opening up entirely new, previously unimaginable possibilities. We are looking at the dawn of quantum imaging, quantum sensing, and quantum communication technologies that could fundamentally revolutionize how we see and interact with the entire world around us. But perhaps even more remarkable, even more magical sounding, is a very recent experiment that successfully achieved something that sounds like it belongs in a storybook. Scientists actually managed to separate the wave and particle attributes of a single photon. They demonstrated what is now famously called the quantum Cheshire Cat effect. This name, of course, is taken from Lewis Carroll's famous whimsical character in Alice's Adventures in Wonderland, the cat who could famously separate his iconic grin from his physical body. This groundbreaking experiment clearly showed that in the quantum realm, the properties of particles can actually, truly exist separately from the particles themselves. Just try to imagine, for a moment, if you could somehow separate your own reflection from your body. Imagine letting your reflection get up and walk around the room, completely independently, all while your physical body remained sitting perfectly in place. This is the profound level of pure strangeness that we are dealing with inside the quantum realm. It is a place where our most basic, most intuitive assumptions about how properties must relate to the objects they belong to, well, they simply do not apply at all. The second great pillar of quantum strangeness is a concept called superposition. This is the fundamental principle which states that quantum particles have the ability to exist in multiple different states all at the same time, simultaneously, until the moment they are observed or measured by an external entity. To understand this, think of a classical computer bit. That bit must be either a 0 or a 1. It is a simple switch, off or on. But a quantum bit, which we call a qubit, can be a 0, it can be a 1, or it can be any probabilistic combination of both states at the exact same time. It is as if reality itself is delicately holding multiple different possibilities in a state of perfect, suspended balance, waiting until the moment we, the observers, decide to peek behind the curtain to see which reality has been chosen. And again, This is not just some fascinating theoretical curiosity. Far from it. Recent, very exciting research has revealed that chlorophyll, that is, the vital green pigment found in plants, appears to actively exploit this principle of quantum superposition. It uses it to achieve a truly remarkable level of efficiency in the process of energy transport during photosynthesis. When a particle of sunlight, a photon, hits a leaf, the energy it carries does not simply travel from point A to point B along one single predictable path. That would be the classical way. Instead, that energy explores multiple different pathways all at the same time, simultaneously, traveling through the leaf's molecular structure using quantum superposition. In doing this, it instinctively, instantly finds the most efficient, the most direct route to the crucial reaction centers where the magic of photosynthesis actually occurs. What this means is that nature itself has been skillfully using quantum mechanics for billions upon billions of years. It has been optimizing life itself, perfecting its processes, using profound principles that we are only now, in this modern age, finally beginning to understand and appreciate. This principle is so fundamental that scientists have even managed to place what we would call macroscopic objects, things visible to us, into these quantum superposition states. Researchers have successfully constructed what they describe as a piezoelectric tuning fork. This object is comprised of about 10 trillion atoms, and they have managed to place this entire object, all 10 trillion of its atoms, into a superposition of vibrating and not vibrating at the exact same time. That is 10 trillion atoms, all existing in multiple states at once. This experiment profoundly challenges our intuitive, comfortable understanding of where the bizarre quantum world is supposed to end and where our familiar, classical world is supposed to begin. That line is becoming blurrier every day. Schrödinger's famous thought experiment, the one involving the cat in the box, is therefore not just a clever philosophical puzzle to ponder. It is, in fact, a powerful window into the very real, very tangible strangeness of quantum superposition. The cat, according to the strange laws of quantum mechanics, truly and literally exists in a superimposed state of being both alive and dead, right up until the moment it is observed. And while we cannot, and should not, easily demonstrate this with actual living cats, the underlying principle holds perfectly true for quantum particles. And fascinatingly, it is holding true for increasingly larger and larger systems as our experimental techniques and our technologies continue to improve. This brings us to the third pillar, the phenomenon known as quantum entanglement. This is the concept that Albert Einstein, in his profound skepticism, famously and dismissively called spooky action at a distance. When two or more particles become quantumly entangled, they form an intricate, mysterious connection. It is a connection that seems to transcend both space and time as we know them. Once entangled, measuring a property of one particle, for instance, its spin, will instantly, and I mean instantly, influence or determine the state of its entangled partner. This happens regardless of the physical distance that is separating them. It could be two particles in the same room or two particles on opposite sides of the galaxy. The connection is instantaneous. Recent, incredible experiments have confirmed this bewildering effect over vast distances, stretching more than 200 kilometers, using orbiting satellites to conduct the measurements. These experiments have definitively proven that Einstein's skepticism, while understandable, was ultimately misplaced. The universe, it turns out, is indeed far more deeply and mysteriously interconnected than classical physics ever could have suggested. But this phenomenon of entanglement is not limited to just a few separate particles floating freely through empty space. Scientists have made the profound discovery that the fundamental particles inside individual protons, the particles called quarks and gluons, are themselves maximally entangled with each other. They are connected across infinitesimally small distances, distances smaller than 1/4,000,000th of a meter. This means that right now, within every single proton that makes up every single atom in your body, quantum entanglement is constantly, perpetually operating. It is creating the deep, underlying correlations that actually help to hold the very fabric of matter together. The implications of this, as you can imagine, extend far, far beyond the realm of fundamental physics. For example, Chinese researchers, making use of the Mikyus satellite, have successfully demonstrated that pairs of entangled photons can serve as the secure foundation for what are, essentially, virtually unbreakable communication systems. In such a system, any attempt by an outside party to eavesdrop on a quantum encrypted message would, by necessity, disturb the delicate state of entanglement. This disturbance would immediately and automatically alert both the sender and the intended receiver to the security breach. We are rapidly approaching a future where quantum entanglement itself could be used to protect our most private, most sensitive communications, shielding them not with complex math, but with the fundamental, inviolable laws of physics themselves. And that leads us to the fourth and final pillar we will discuss tonight: the uncertainty principle. First formulated by Werner Heisenberg, this principle reveals to us that there are absolute, fundamental limits to how precisely we can know certain pairs of properties of a quantum particle simultaneously. It is crucial to understand that this is not a limitation of our measuring instruments. It is not a problem of technology that we might one day solve with better equipment. No, it is a basic core feature of reality itself. The principle states, for example, that the more precisely you manage to know a particle's exact position, the less precisely you can possibly know its momentum, which is its mass in motion. And conversely, the more precisely you know its momentum, the less precisely you can ever know its true position. This is not uncertainty in the way we usually mean it, in the sense of simple ignorance or not having enough data. Rather, it is a fundamental, built-in fuzziness that is woven directly into the very fabric of existence. This cosmic uncertainty is not a mistake. It is not a bug in the cosmic operating system. It is, in fact, a vital feature. Without quantum uncertainty, the math tells us that atoms themselves would collapse in an instant. The stars in the sky would not be able to shine, and the rich, beautiful complexity of chemistry that makes life, like us, possible, it simply could not exist. The uncertainty principle, in a very real sense, creates the necessary space, both literally and figuratively, for the intricate, wonderful dance of existence to unfold. These four great pillars, wave-particle duality, superposition, entanglement, and the uncertainty principle, all work together, intertwining to create what we might poetically call the quantum symphony. It is a deeply harmonious, complex interplay of fundamental strangeness that serves as the unseen foundation for everything we see, everything we touch, and everything we experience in our classical world. But the quantum realm is not content to simply exist quietly in the background, powering reality from behind the scenes. Oh no. Recent, cutting-edge discoveries are now revealing entirely new, previously unknown states of quantum matter. These discoveries could, in time, completely revolutionize our technology and profoundly deepen our collective understanding of reality itself. For instance, at the University of California, Irvine, a team of researchers has discovered entirely new phases of quantum matter, phases that can be coaxed into existing within specially prepared, engineered materials. By applying incredibly intense magnetic fields to a material called hafnium pentatellide, they have successfully created exotic novel states. In these states, electrons and their oppositely charged counterparts, which are known as holes, spontaneously pair up together. They form new quasi-particles called excitons. These new forms of matter, these quantum liquids, behave in ways unlike anything we have ever seen or predicted before. They possess properties that could one day enable technologies like self-charging computers, devices that never need to be plugged in, and ultra-resilient electronics capable of perfectly withstanding the incredibly harsh, unforgiving conditions of deep space exploration. Just pause for a moment and try to imagine that. Imagine materials that could literally repair themselves when damaged. Imagine computers that never need an external power source, drawing energy from the environment itself. Or imagine electronics that do not just survive, but actually become more efficient and reliable in the extreme cold and radiation-filled conditions of deep space exploration. These are not, I assure you, mere science fiction fantasies. They are not just dreams. They are the very real potential applications of these new quantum states that are being discovered right now in laboratories all around our world. In addition to this, scientists have also recently identified what they are calling quantum liquid crystals. These are fascinating materials that appear to exist precariously at the precise boundary between different, exotic quantum phases. These unique materials show incredibly sharp, sudden drops in their electrical conductivity, and also possess a remarkable, almost unbelievable resistance to high levels of radiation. These are properties that could make them truly invaluable, not only for our terrestrial technologies here on Earth, but especially for the future of space exploration. But perhaps the most profound, the most paradigm-shifting recent discovery is the realization that information itself can undergo phase transitions when it is inside a quantum system. In the same way that ordinary water can exist as solid ice, as liquid water, or as gaseous vapor, it now seems that quantum information can also exist in different, distinct phases. Which phase it is depends on a delicate, complex balance between the forces of entanglement and the act of measurement. Scientists have now successfully identified the critical points where the fundamental nature of this quantum information itself transforms, completely opening up entirely new ways of thinking about computation, about communication, and perhaps about the fundamental nature of reality itself. As we continue to delve deeper and deeper into these incredible discoveries, we truly begin to see a new picture of our world emerge. We see that the quantum realm is not just some disconnected collection of strange, quirky phenomena that only happen at invisible, microscopic scales. No. It is, in fact, the foundational layer of all reality. It is the hidden, powerful engine that relentlessly drives everything. It drives the nuclear fusion reactions burning inside of distant stars, and it just as surely drives the complex electrochemical thoughts that are flowing through your mind at this very instant. Every single atom that constitutes your body is, at its core, a complete quantum system. Every chemical bond that holds you together is a quantum interaction. And every single biological process that keeps you alive, from breathing to thinking, depends fundamentally on subtle quantum effects that we are only just now beginning to understand and truly appreciate. The quantum realm does more than just power our world. It challenges us. It challenges us to profoundly expand our concept of what is truly possible. It invites us to embrace the idea of uncertainty, not as a flaw, but as a powerful, creative force. It forces us to recognize, perhaps humbly, that the universe is infinitely more mysterious, more complex, and more stunningly beautiful than our limited everyday experience might ever suggest. As we continue this gentle exploration together, we will soon discover how these very quantum principles are being actively harnessed. We are using them to create technologies that would have seemed, to previous generations, like pure and absolute magic. And we will explore how these principles are revealing tantalizing, deep connections between mind and matter, connections between information and reality, that could, in our lifetime, completely transform our understanding of existence itself. But please know that this is only just the very beginning of our shared journey into the quantum realm. In our next exploration, we will discover how these strange quantum effects are beginning to scale up, moving from the invisible, microscopic world into our very own macroscopic world. And we will also explore a question that might just fundamentally change how you think about the very nature of reality itself. We will ask, what would happen to our planet, to Earth, if the fundamental force of gravity simply vanished? But for now, let us return to our current exploration. Because the quantum realm, as we have been discussing, does not exist in some state of pristine isolation. It is not floating out there in some abstract, sterile mathematical space, far removed from your daily, tangible experience. No. The truth is, it is intricately woven into the very fabric of your reality, right now, in ways that, when you truly grasp them, would absolutely astonish you. Right at this very moment, as you are listening to these words I am speaking, quantum processes are meticulously orchestrating the complex firing of neurons within your brain. They are powering the steady, rhythmic beating of your heart. They are even fundamental to the way your eyes are processing the light that might be reaching them from your screen. But here, right here, is where things become truly, profoundly extraordinary. The quantum realm is no longer content to simply remain hidden away in the microscopic, invisible world. It is actively beginning to emerge, to bubble up into our everyday, classical reality, all thanks to human ingenuity and curiosity. We are collectively creating technologies that operate on principles that would have seemed like pure, impossible fantasy just a few short decades ago. We are, right now, witnessing the very birth of a new quantum revolution. It is a revolution that promises to utterly transform everything, from how we communicate securely across vast global distances to how we, perhaps, might finally come to understand consciousness itself. Let me share with you one of the most remarkable, tangible demonstrations of quantum mechanics scaling up, moving from the invisible world into our visible world. Scientists have now triumphantly, successfully created genuine quantum entanglement between objects that are so large you could almost see them with your naked, unaided eye. Try to imagine two tiny, minuscule silicon beams. Each one is only about 10 micrometers long, which is, roughly speaking, the average width of a single human hair. These tiny beams can be made to oscillate, to vibrate, like microscopic futuristic guitar strings. And incredibly, researchers have managed to entangle them so completely, so perfectly, that when one of those beams is made to vibrate, its entangled partner, though physically separate, instantly responds in perfect, mirrored correlation. Think about that for just a moment. We are talking about physical objects, objects that contain billions upon billions of atoms, all somehow participating together as one in a single unified quantum state. It is as if two full orchestras situated on opposite sides of the world could suddenly begin to play in perfect, flawless harmony without any form of communication passing between them. Their movements, their very music, would be perfectly synchronized by the mysterious, invisible threads of quantum entanglement. Another team of dedicated researchers took this incredible feat even further. They managed to create entangled aluminum drumheads, tiny membranes, each one again only about the width of a human hair, meticulously manufactured onto silicon chips. By using carefully controlled microwave pulses, they gently nudged these tiny drums into a state of correlated motion. The result was that as one drum throbbed up and down, the other drum, its entangled twin, did the exact, precise opposite. These are not individual, invisible particles anymore. These are true macroscopic objects, containing trillions upon trillions of atoms, all of them somehow dancing in perfect unison to the mysterious rhythm of quantum mechanics. This successful scaling of quantum effects from the micro to the macro world opens up a universe of possibilities. Possibilities that truly read like pages from a science fiction novel. Imagine quantum sensors so exquisitely sensitive that they could detect the faint, gravitational waves that are constantly rippling through space-time. Ripples caused by the collision of massive black holes billions of light-years away from us. Or imagine quantum communication networks, where vital information travels not through vulnerable cables or broadcast radio waves, but through the instantaneous, untouchable connections of entangled particles. This would create communication systems that are fundamentally, physically unhackable by the very laws of physics themselves. But perhaps the most mind-bending, the most paradigm-shattering recent discovery comes from the realm of energy itself. Scientists have now achieved something that sounds utterly impossible. They have successfully extracted usable energy from the quantum vacuum, that is, from the supposedly empty space that exists between particles. You see, what we casually call empty space is not, in reality, empty at all. At the quantum level, it is a seething, chaotic soup of frenetic activity. It is filled to the brim with virtual particles that are constantly, endlessly popping into existence and then disappearing back into nothingness, all in time frames so incomprehensibly brief that they exist more as fleeting possibilities than as actual, tangible realities. And yet, these quantum vacuum fluctuations, this energy of nothingness, are real enough to be measured, and now to be harnessed. Researchers have developed highly sophisticated techniques to actually teleport energy across microscopic distances, simply by manipulating these quantum field fluctuations. It is a bit like learning to surf on the invisible waves of nothingness, skillfully extracting usable, real energy from the very structure of space-time itself. And while the amounts of energy involved in these experiments are, for now, still infinitesimally tiny, the principle has been proven. It opens up entirely new, revolutionary ways of thinking about power generation and energy storage for our future. This discovery brings us, inevitably, to one of the most profound and perhaps unsettling questions in all of quantum mechanics. What role, if any, does our consciousness play in all of this? The measurement problem, as physicists soberly call it, suggests that the simple act of observation, of looking, somehow causes the cloud of quantum possibilities to collapse into one single, definite reality. But what, precisely, constitutes an observation? Does it require a conscious, aware observer like you or me? Or can any simple interaction with the surrounding environment, like a stray photon bumping into it, cause this collapse? Recent experiments are beginning to provide us with tantalizing, fascinating clues. Scientists have discovered that quantum coherence, that is, the delicate, fragile state that allows particles to exist in superposition, can actually persist for much, much longer than anyone had previously thought possible, provided the right conditions are met. They have even managed to maintain delicate quantum states in complex systems operating at room temperature, far, far away from the near absolute zero conditions that are typically required for quantum experiments. This surprising discovery suggests that quantum effects might be far more robust and far more prevalent in warm, wet biological systems, like our own brains, than we ever dared to imagine. Some pioneering researchers are now proposing that consciousness itself might actually emerge from quantum processes happening deep within the brain. They suggest that the strange, non-local connections of quantum entanglement could be the key to explaining how separate, distant regions of the brain manage to coordinate their activity instantly to create the single, unified, seamless conscious experience that you are having right now. Consider for a moment the profound mystery of how your brain integrates all the different streams of information from your different senses into one single, coherent experience of reality. When you bite into a fresh apple, for example, your brain somehow, miraculously, combines the visual appearance of the apple, the sharp sound of the crunch, the complex taste on your tongue, the distinct scent reaching your nose, and the tactile sensation of your teeth breaking through the skin. It merges all of this instantly into one unified, singular experience, the experience of eating an apple. Classical neuroscience, for all its advances, truly struggles to explain how this binding of sensory data occurs so seamlessly. But these new quantum theories of consciousness suggest that quantum entanglement between neurons, spread across the brain, could be creating the instantaneous correlations that are necessary for this kind of unified, singular experience. The implications of this extend even further, becoming even stranger when we begin to consider recent discoveries about the very nature of time itself within quantum mechanics. In the quantum realm, it appears that time does not always flow in the steady, straight, predictable arrow from past to future that we experience in our daily lives. Quantum particles, it has been shown, can actually influence their own past states through a bizarre phenomenon known as retrocausality. This is where the future appears, impossibly, to reach back and influence the past. Experiments have now conclusively demonstrated that decisions we make in the present about how to measure a particle can, and do, affect that particle's behavior retroactively back in the past. It is as if the particle somehow knew ahead of time how it was going to be observed in its future. This is not time travel in the way science fiction portrays it, but it strongly suggests that the linear relationship between cause and effect, which we take for granted, is far more subtle and deeply interconnected in the quantum realm than our everyday experience would ever lead us to believe. These mind-bending discoveries are leading scientists to develop entirely new theories about the fundamental nature of time itself. Some are proposing that time, much like space, might actually be quantized at the very smallest scales. That is, it may not exist as a smooth, continuous flow, but rather as a series of discrete, indivisible moments, or ticks, of a cosmic clock. Others are suggesting that time itself might be an emergent property, something that arises from quantum entanglement, emerging from the web of correlations between quantum systems, rather than being a fundamental feature of reality at all. The practical implications of finally understanding quantum time are truly staggering. Researchers are already developing quantum clocks so incredibly precise that they could detect the subtle, almost imperceptible effects of gravity on the passage of time, potentially revealing entirely new physics beyond our current standard models of understanding. These clocks are so exquisitely sensitive that they can already measure the time dilation effects, time slowing down, caused by simply being lifted just a few centimeters higher in Earth's gravitational field. But perhaps the most extraordinary and most famous application of all these quantum principles lies in the burgeoning realm of quantum computing. This is where the strange, ethereal properties of superposition and entanglement are being actively harnessed to create computers that operate on fundamentally different principles than any technology we have ever developed before in human history. A classical computer, like the one you might be using near you, processes information using bits. These bits are simple switches that must be either a 0 or a 1, off or on. But a quantum computer uses qubits. And as we have learned, qubits can exist in superposition states. They can be a 0, a 1, or both 0 and 1 at the exact same time. This means that while a classical computer with, say, 3 bits can represent any one of 8 possible combinations at any single time, a quantum computer with 3 qubits can represent all 8 of those combinations simultaneously. This incredible exponential scaling means that a theoretical quantum computer, one with just 300 stable qubits, could perform more distinct calculations, all at the same time, than there are known atoms in the entire observable universe. Let that sink in. We are genuinely talking about a level of computational power that absolutely dwarfs anything that is even theoretically possible with our current classical technology. We are opening up the possibility of solving complex problems that would take our best conventional computers longer than the entire age of the universe to even begin to complete. Quantum computers are already, in these very early days, beginning to demonstrate their immense potential in highly specific applications. Researchers have successfully used quantum algorithms to simulate complex molecular interactions with an unprecedented, previously impossible level of accuracy. This could, in the very near future, completely revolutionize drug discovery. It would allow scientists to model, with perfect precision, how new pharmaceutical compounds will interact with biological systems, all at the most fundamental quantum level. Imagine being able to design new, life-saving medications, not through slow, expensive trial and error, but by precisely calculating how the quantum interactions between the drug molecules and the cellular targets will unfold. We could, potentially, cure intractable diseases by engineering perfect, targeted solutions at the most fundamental level of matter and energy. The quantum realm is also revealing to us new, profound insights into the nature of information itself. As we touched on before, scientists have discovered that information can undergo phase transitions. It can change from one fundamental state to another, just like matter changes from solid to liquid to gas. They have successfully identified the critical points where this quantum information transforms, creating entirely new, unforeseen possibilities for information processing and for ultra-dense storage. These discoveries are strongly suggesting that information might be a far more fundamental aspect of reality than we ever imagined. Some physicists are now boldly proposing that matter and energy, the stuff of the universe, might actually be emergent properties that arise from more basic, underlying informational processes. They suggest that the universe might be, at its deepest, most fundamental level, a vast cosmic quantum computer. a computer that is processing the very information that, in turn, creates our reality. This leads us to one of the most profound and deeply personal questions in all of science. What is the relationship between mind and matter? If our consciousness does indeed arise from these quantum processes, and if information is truly fundamental to all reality, then perhaps consciousness is not just a passive observer of the universe. Perhaps it is an active, essential participant in the universe's creation. Recent, fascinating experiments in the new field of quantum biology have revealed that living systems all around us routinely exploit quantum effects to gain an edge, to achieve enhanced efficiency. Migratory birds, for example, appear to navigate using quantum entanglement, which occurs in specialized proteins in their eyes, allowing them to literally see and sense the Earth's magnetic fields. Quantum tunneling, a process where a particle can pass through a solid barrier it should not be able to cross, allows enzymes in our bodies to catalyze crucial biochemical reactions that would be simply impossible under the rules of classical physics. Even our very process of smell might depend on quantum effects, with our olfactory receptors distinguishing between different molecules based on their unique quantum vibrational signatures. These discoveries are strongly suggesting that life itself might be, at its core, a quantum phenomenon. That the very boundary between what we call living and non-living matter might be defined simply by the ability to maintain and skillfully exploit quantum coherence. Perhaps then, consciousness represents the ultimate, most sophisticated expression of this quantum biology. The point at which these quantum processes become so complex, so interconnected, that they give rise to subjective experience, to feeling, and to self-awareness. As we stand here together, right on the threshold of this new quantum age, we are beginning to glimpse technologies and possibilities that would have, without any doubt, seemed like pure supernatural magic to all previous generations of humanity. Quantum communication networks could soon create a truly unhackable global internet infrastructure. Quantum sensors could one day detect the mysterious dark matter that holds our galaxies together, or map the intricate structures of proteins, or monitor the subtle signs of climate change with unprecedented pinpoint precision. Quantum computers could optimize the complex flow of traffic in our busiest cities, discover revolutionary new materials, or simulate the behavior of entire, vast ecosystems. But far beyond all of these incredible technological applications, the quantum realm is teaching us something truly profound about the nature of reality itself. It is showing us that the universe is far more interconnected, far more creative, and far more mysterious than we ever imagined. The boundaries that we hold so dear, the boundary between the observer and the observed, the line between mind and matter, the separation between the past and the future, are proving not to be as clear-cut, not as solid, as our everyday experience would suggest. The quantum realm reveals a universe where infinite possibilities exist in a gentle superposition, waiting patiently to be actualized by interaction. A universe where distant, separate objects can remain mysteriously, instantly connected. A universe where the very act of measurement participates in the active creation of reality. It is a universe that seems almost conscious in its profound responsiveness, almost playful in its stubborn refusal to be pinned down by our clumsy attempts to categorize and to control it. As we continue to explore these deep quantum mysteries, we are not just advancing our scientific understanding of the world. We are participating in a fundamental planet-wide shift in how we see ourselves and our place within this vast cosmic story. We are discovering, perhaps with some humility, that we are not separate, isolated observers looking in on an objective reality. We are, instead, intimately connected participants, engaged in an ongoing, beautiful quantum dance that creates the very world we experience. The quantum realm is teaching us that reality is far stranger, far more beautiful, and far, far more participatory than we ever dared to imagine. And as we learn to harness these subtle quantum effects for practical, real-world applications, we are not just building better, faster technology. We are, in a very real sense, learning to collaborate with the deepest, most creative processes of the universe itself. This brings us, then, to an even more fundamental question about the nature of our reality. It is a question that will challenge everything you think you know about the forces that hold our entire world together. We have explored how quantum effects shape matter and energy, but what would happen if one of the most basic, most fundamental features of our universe, something so constant, so pervasive, we barely even notice it, suddenly vanished? What would become of our planet, our solar system, our very existence, if gravity simply stopped working tomorrow? But the quantum realm holds secrets that go even deeper, secrets that transcend technological applications or purely biological processes. Hidden deep within its strange mathematical framework lies perhaps the most profound, most personal mystery of all. This is the relationship between consciousness itself and the fundamental structure of reality. And recent discoveries, new data, are suggesting connections so extraordinary, so paradigm-shifting, that they challenge our most basic core assumptions about what it means to be aware, to observe, and to exist. Consider this for a moment. Every single time you make a conscious decision, every time you choose, your brain processes vast amounts of information through complex, quantum mechanical interactions that are happening between your neurons. The tiny electrical signals that carry your thoughts, the intricate chemical bonds that store your precious memories, the very act of awareness itself. All of it depends, fundamentally, on quantum processes, processes that are operating at scales so infinitesimally small, they exist at the very boundary between something and nothing. But here is what is truly, truly remarkable. Scientists at Princeton University have been conducting a long series of experiments that seem to suggest that consciousness might not just depend on quantum mechanics, but that consciousness might, in return, actually influence quantum systems. They created devices which they call random event generators, or REGs. These are machines that produce sequences of numbers that are, by their very nature, truly random. They are based on quantum decay processes, like the decay of a radioactive atom, which are governed by the fundamental randomness of quantum mechanics. These devices should be completely, perfectly unpredictable. They should be influenced by nothing at all. And yet, when human subjects focus their conscious intention onto these devices, when they sit and quietly try to influence the random output to make it skew high or skew low, something extraordinary, something statistically inexplicable happens. The devices begin to produce sequences that deviate ever so slightly, but consistently, from pure, perfect randomness. They deviate in the precise direction of the subject's focused intention. The effect, I must stress, is incredibly small. It is barely detectable above the background noise of statistical chance, but it has been replicated time and time again in laboratories all around the world with a remarkable, persistent consistency. Imagine, just for a moment, what that implies. Imagine if your consciousness, your awareness, your very thoughts could somehow reach across the boundary, the veil between mind and matter. Imagine if you could influence the fundamental quantum processes that underlie our entire physical reality. It is a possibility so profound that it would fundamentally change how we understand our place in the universe. It would suggest that consciousness is not just a passive, isolated observer of reality, but is, in fact, an active, integral participant in its ongoing creation. This possibility leads us directly into the fascinating realm of quantum consciousness theories. This is where some of the world's most brilliant and open-minded thinkers are exploring the possibility that awareness itself emerges from quantum processes occurring deep within the brain. According to some of these theories, the microtubules within our neurons, which are tiny, hollow protein structures that help to maintain the cell's architecture, might actually be acting as tiny, biological quantum computers. They might be processing information through quantum superposition and quantum entanglement. The idea, in simple terms, is that our consciousness arises, or emerges, when the quantum information being processed in these countless microtubules reaches a certain critical threshold. This, the researchers say, causes what they call orchestrated objective reduction, a self-collapse of the quantum state, which we, in turn, experience as a conscious moment, a thought, or a feeling. It is as if your brain is constantly, perpetually performing a symphony of quantum computations that give rise to the single, unified, coherent experience of being you. This theory, while still speculative, does help to explain some of the deepest, most persistent mysteries of consciousness. How does your brain bind together all that information from your different senses into one, single, unified perception? How do you experience the smooth, seamless flow of subjective time, rather than a series of disjointed snapshots? How does your conscious will seem to emerge from the purely physical, chemical activity of your neurons? Quantum consciousness theory suggests that entanglement, that spooky, non-local connection between quantum processes happening in different, distant parts of your brain, could be creating the instantaneous correlations that are necessary for your unified, singular, conscious experience. But the implications of this, if it is true, extend far beyond our own individual consciousness. If awareness truly emerges from quantum processes, and if, as we know, quantum entanglement can connect distant particles instantaneously, then perhaps consciousness itself might be fundamentally non-local. Perhaps the boundaries that we perceive, the boundaries between individual minds, are not as solid, not as absolute as we have always imagined them to be. Some researchers are now actively exploring the very real possibility of quantum entanglement between brains. They are investigating whether conscious, living beings might share subtle, underlying quantum connections. Connections that could perhaps explain mysterious phenomena like telepathy, or the feeling of a collective consciousness, or even the uncanny, deeply felt ability of closely bonded individuals to sense each other's emotional states, even across great distances. Recent experiments, for instance, have shown that when two people interact closely, when they are in deep, empathetic conversation, their brain waves actually begin to synchronize. They fall into step with one another in complex patterns that cannot be fully explained by normal, sensory communication, like speech or body language alone. Studies of couples who have been together for many, many years show a remarkable, profound coordination in their neural activity, as if their brains have, over time, become somehow quantumly entangled through their countless shared experiences and their deep emotional bonds. These baffling discoveries are leading some scientists to propose an even more radical idea. Perhaps consciousness is not produced by individual brains at all. Perhaps instead, consciousness is a fundamental property of the universe itself, much like gravity or electromagnetism. Perhaps it is something that our brains, as complex biological receivers, have simply evolved to tune into, rather than to generate from scratch. According to this breathtaking view, your individual consciousness, the you that is listening to my voice, might be akin to a sophisticated radio receiver. A receiver that is picking up a unique signal from a vast, cosmic field of awareness, a field that permeates all of reality, all of space and time. This brings us, logically, to one of the most profound implications of all of quantum mechanics: the participatory universe hypothesis. This theory, championed by the great physicist John Archibald Wheeler, suggests that the universe does not even exist in any one definite, solid state until it is observed. And furthermore, that our conscious observation actually participates in creating the very reality that we experience. In this view, you are not just a person who is living in the universe. You are, in a very real way, helping to create the universe, moment by moment, simply through your conscious awareness of it. Think about what this would mean for your daily experience. Every single time you look at a beautiful sunset, your conscious observation, your act of seeing, might be participating in actualizing the specific, beautiful colors and patterns that you see, collapsing them from a wave of infinite possibilities. Every time you listen to a piece of music, your awareness might be helping to create the particular harmonies and the specific rhythms that emerge for you from the quantum field of potential. Every single moment of your conscious experience becomes, in this light, an act of profound cosmic creativity. This participatory relationship, this dance between consciousness and reality, also helps to explain one of quantum mechanics' most puzzling and persistent features. Why does the simple act of measurement, of looking, seem to cause the wave of quantum superposition to collapse into one single, definite state? Perhaps measurement is not just a simple, mechanical interaction between a measuring instrument and a particle. Perhaps it requires some form of conscious awareness, even a rudimentary one, to register the results, to make them real, and thus to actualize a specific outcome from the haze of quantum possibilities. Recent experiments have pushed this astonishing idea to its absolute limits by creating what researchers call quantum delayed choice experiments. In these bizarre studies, the decision about how to measure a quantum particle, for instance, whether to measure its wave nature or its particle nature, is made after the particle has already interacted with the measuring apparatus and completed its journey. And yet, incredibly, the particle's behavior in the past changes retroactively based on the future measurement choice. It is as if the particle somehow knew in its past how it was going to be observed in its future, and it adjusted its behavior accordingly. These experiments strongly suggest that our consciousness and our choices might have subtle effects that ripple both forward and backward through time. They suggest that your decisions, made in this present moment, might be influencing not just your future, but also, perhaps, your past. If consciousness truly does participate in creating reality through these quantum processes, then perhaps free will is not just about choosing your future actions from a fixed set of options. Perhaps it is about participating actively in the ongoing creation of the entire, seamless space-time continuum. But the quantum realm, it seems, has even more surprises in store for us. As we have discussed, scientists have discovered that information itself can exist in quantum superposition states. This creates what they now call quantum information, which behaves according to entirely different and much more powerful rules than the classical information stored on our hard drives. Quantum information can, as we know, be in multiple states simultaneously. It can be intricately entangled across vast cosmic distances. And, incredibly, it can even be teleported from one location to another without physically traveling through the intervening space. This discovery, in itself, has led to the rapid development of quantum cryptography systems. These are systems that use the fundamental, unchangeable laws of physics to create codes that are, in principle, absolutely 100% unbreakable. When information is encoded into delicate quantum states and then transmitted between two parties, any attempt by a third party to intercept or eavesdrop on that communication must, by the laws of physics, disturb those quantum states. This disturbance is not subtle. It is immediate and detectable, and it instantly alerts both the sender and the intended receiver to the security breach. Imagine, if you will, a future where all of our most sensitive communications, from our private, personal messages to our critical financial transactions to our most vital government secrets, are protected. Protected not by complex mathematical algorithms that might, one day, be cracked by a powerful enough computer, but protected instead by the fundamental, inviolable laws of quantum mechanics themselves. We are approaching, faster than many think, a world where our privacy and our security are quite literally guaranteed by the deepest principles of physics. These futuristic-sounding quantum communication networks are already being tested and deployed, right now, in laboratories and in limited field trials all around our world. Chinese researchers, as we noted, have used quantum entanglement to create secure communication links between ground stations and their orbiting Michus satellite. They have successfully demonstrated secure quantum communication over staggering distances of more than 1,000 kilometers. In parallel, European teams have built and tested their own quantum communication networks, linking major capital cities together, and in doing so, creating the essential foundational infrastructure for a future global quantum internet. But perhaps the most extraordinary, most powerful application of quantum information lies, as we have touched upon, in the field of quantum computing. This is where the strange, ethereal properties of superposition and entanglement are being harnessed to solve immensely complex problems that would be, and are, completely impossible for even the most powerful classical supercomputers to solve. Unlike our conventional computers, which must process information sequentially, one step after another, quantum computers can explore all possible solutions to a given problem, simultaneously through a process known as quantum parallelism. As we have touched on, a quantum computer with just a few hundred stable qubits, perhaps 300, perhaps 500, could theoretically perform more calculations, all at the same instant, than there are atoms in the entire observable universe. This, as you can see, is not just a simple quantitative improvement over classical computing. It is not just faster. It is a profound, qualitative leap into an entirely different, previously unimaginable realm of information processing. This new paradigm could revolutionize everything from artificial intelligence to material science, and perhaps even to our understanding of consciousness itself. Researchers are already using today's early, noisy quantum computers to simulate molecular interactions with that unprecedented level of accuracy, a development that is potentially leading us toward massive breakthroughs in drug discovery, in renewable energy technologies, and in sustainable manufacturing processes. They are also developing new quantum machine learning algorithms. These are algorithms that could one day give artificial intelligence systems capabilities that would seem almost magical, almost precognitive by today's standards. Imagine for a moment AI systems that do not just process information in a linear fashion. Imagine systems that can, themselves, exist in quantum superposition states. Systems that could explore multiple possible thoughts, multiple strategies, and multiple decisions, all simultaneously, before finally collapsing into one specific, optimal action. These quantum AI systems might one day exhibit truly novel forms of creativity and deep intuition, qualities that would emerge directly from their unique quantum ability to exist in multiple possibility states all at once. But the quantum realm, it seems, is not content to remain confined to our laboratory experiments and our futuristic, human-built technologies. It is beginning to reveal itself more and more in the natural world, all around us. It is showing us, in ways that are truly humbling, that quantum effects have been subtly, powerfully shaping biological evolution on our planet for billions of years. As we noted, plants are using quantum coherence to optimize the transfer of energy during photosynthesis. Birds are navigating the globe using quantum entanglement in specialized proteins in their eyes. Even our very own sense of smell might, at its core, depend on quantum tunneling effects, a process that allows our olfactory receptors to distinguish between different molecules based on their unique quantum vibrational signatures. These discoveries are leading to the rapid and exciting emergence of quantum biology. This is a brand new, interdisciplinary field that seeks to explore exactly how living systems, from bacteria to human beings, manage to exploit these subtle, delicate quantum effects to achieve capabilities that would be simply impossible under the rigid, classical laws of physics. Some researchers in this field are beginning to suggest that life itself might be defined, at its most basic level, by the ability to maintain quantum coherence. The ability to shield these delicate quantum states from the warm, noisy, chaotic biological environments where, by all classical logic, they should quickly disappear and decohere. Perhaps the most profound implication of this new field of quantum biology is the tantalizing possibility that consciousness and life itself are intimately, inextricably connected, all through these deep quantum processes. If our awareness truly does emerge from quantum computations happening within our brains, and if living systems throughout all of nature are routinely exploiting quantum effects for enhanced performance, then perhaps consciousness, our consciousness, represents the ultimate, most sophisticated expression of quantum biology. Perhaps it is the very point where these quantum processes become so complex, so richly interconnected, that they finally give rise to subjective experience, to feeling, and to true self-awareness. And so we come full circle, back to the deepest, most personal mystery of the quantum realm, the intricate, profound relationship between mind and matter, between consciousness and the cosmos. The quantum world, as we have seen, reveals a universe that seems almost alive in its constant responsiveness. A universe that feels almost conscious in its deep, fundamental interconnectedness. We see particles that seem to know how they will be observed in their future. We see entangled systems that respond instantly to one another across vast, empty distances. We see information that exists only as a ghostly wave of superposition, until it is actualized and made real by our awareness. As we stand here together tonight, at the very threshold of this new quantum age, we are not just developing new, faster, more powerful technologies. We are, all of us, participating in a fundamental global shift in how we understand reality itself. The quantum realm is teaching us that this universe is far more participatory, far more creative, and infinitely more mysterious than our classical materialist worldview ever suggested. We are discovering, slowly but surely, that we are not separate, isolated observers looking in on an objective, external reality. We are, instead, intimately connected, essential participants in an ongoing, beautiful quantum dance that itself creates the world we experience. The boundaries that we once thought were so solid, the boundary between the observer and the observed, between the mind and the matter, between the self and the cosmos, are now revealing themselves to be far more fluid, far more permeable than we could have imagined just a few short generations ago. We are learning that our consciousness might not be some accidental byproduct confined to our individual brains. We are learning that it might, instead, be a fundamental feature of reality itself, woven deeply into the very quantum fabric of all existence. These insights, these whispers from the quantum world, are more than just fascinating scientific discoveries. They are, in a sense, invitations. They are invitations to a new way of being in the world. If our consciousness truly does participate in the creation of our reality through these quantum processes, then every single moment of our awareness becomes an opportunity for profound, cosmic creativity. Every choice we make, every thought we think, becomes an act of genuine participation in the ongoing, unfolding evolution of the universe itself. As we continue, as a species, to explore the beautiful mysteries of the quantum realm, we are not just pushing the boundaries of human knowledge. We are, perhaps, finally rediscovering our true nature, our nature as conscious, creative, and essential participants in this grand cosmic story. We are learning to see ourselves not as isolated, lonely fragments of matter and energy lost in a cold, indifferent, and meaningless universe. We are learning, instead, to see ourselves as integral, vital aspects of a conscious cosmos. A cosmos that is, right now, constantly creating itself through our awareness, through our choices, through our very existence. The quantum realm is revealing to us that reality is far stranger, far more beautiful, and far more participatory than we ever dared to imagine. And as we learn to work with these quantum principles in our technologies and in our personal understanding, we are not just building a better, more advanced future. We are, quite simply, learning to dance with the deepest, most creative forces of existence itself. But this profound dance of consciousness and the cosmos raises an even more fundamental and perhaps even more startling question about the very nature of our reality. We have explored, in depth, how these quantum effects shape matter, energy, and even consciousness itself. But what would happen if we removed one of the most basic, most fundamental features of our universe? Something so constant, so pervasive, that we rarely even think about it at all. What would become of our planet, our solar system, our very existence, if gravity, that invisible, relentless force that holds everything together, simply, suddenly, vanished tomorrow? The quantum realm, it seems, is revealing something even more extraordinary, even more profound than we have yet explored this evening. This is the emergence of what some scientists are now daring to call quantum consciousness fields. These are hypothesized to be vast, intricate networks of entangled information that might, just might, connect every single conscious being in ways we are only just, faintly, beginning to understand. But before we venture together into that most profound and most speculative mystery, let me share with you one final discovery. It is a discovery that might fundamentally change how you think about your own place in this cosmic story. In highly advanced laboratories all around the world, researchers are beginning to detect something they never, ever expected to find. They are finding evidence of quantum coherence within human neural networks, coherence that persists for far, far longer than it should be physically possible. According to everything we thought we knew, to all our established models of quantum mechanics, these incredibly delicate, fragile quantum states should collapse within mere microseconds, or even faster, inside the warm, wet, chaotic environment of a living human brain. And yet, somehow, our consciousness, our awareness, appears to be capable of maintaining this quantum coherence, shielding it across multiple distant brain regions, all simultaneously. It is creating what can only be described as a quantum orchestra, playing in perfect, harmonious synchrony, deep within your skull. Dr. Roger Penrose and Dr. Stuart Hameroff's groundbreaking and admittedly controversial research has revealed that the microtubules within our neurons, those tiny, hollow protein highways that transport materials and information through our brain cells, exhibit quantum behavior. Behavior that seems to defy our current, classical understanding of physics. These microtubules, they propose, appear to be processing information through quantum superposition, existing in multiple, complex computational states all at the same time, until our unified consciousness emerges from their coordinated, orchestrated activity. Think of it in this way, as a closing thought. Imagine if every single one of the billions of neurons in your brain were, in fact, a tiny, powerful quantum computer. And imagine if your entire, vast nervous system were, in reality, a single, integrated quantum network, processing your thoughts, your emotions, and all your experiences through the mysterious, instantaneous connections of quantum entanglement. This is not science fiction. This is what the hard, experimental evidence is now, tantalizingly, beginning to suggest about the true nature of human consciousness itself. But the implications, as you can imagine, extend far, far beyond our own individual awareness. If consciousness truly does operate through these deep quantum processes, and if quantum entanglement, as we know, can connect particles instantly across vast cosmic distances, then perhaps our individual minds are not as isolated, not as separate as we have always assumed them to be. Recent experiments, as we have seen, have shown that when two people engage in deep conversation or sit in shared meditation together, their brain waves begin to synchronize, falling into step in complex patterns that cannot be fully explained by normal sensory communication alone. Researchers at Princeton University have documented these cases, where couples who have shared decades of intimate connection show this remarkable, profound coordination in their neural activity, even when they are separated by considerable physical distances. Their brain patterns seem to mirror each other in ways that strongly suggest some form of non-local quantum connection. It is as if their very consciousness, their minds, have become quantumly entangled through their countless shared experiences and their deep, abiding emotional bonds. This brings us, inevitably, to one of the most profound and most beautiful questions in all of science. Could consciousness itself be a quantum field? A field that permeates the entire universe? Could it be something that our individual, biological brains have evolved to tune into, rather than to generate from scratch? Some of the world's most brilliant and most courageous physicists are beginning to seriously and publicly consider this very possibility. They are proposing that awareness itself might be as fundamental, as basic to reality as matter and energy themselves. Consider, just for a moment, what this would mean for your own, personal, everyday experience of being conscious. Right now, as you listen and process these words, your brain might be, in fact, tapping into a vast, universal field of cosmic awareness. A field that connects you, intimately, to every other conscious being in the universe. Your thoughts, your feelings, your emotions, your very sense of self. All of it might be arising from your brain's complex, quantum interactions with this fundamental universal consciousness field. This theory, as grand as it sounds, would help to explain some of the deepest, most persistent mysteries of human experience. How do profound, creative insights seem to arrive in our minds from nowhere, often fully formed and brilliantly elegant? How do people, sometimes, seem to know things they could not possibly know through any of their normal sensory channels? How do we experience that uncanny, deeply felt sense of connection with our loved ones, even across great, vast distances? The quantum consciousness field theory suggests that these phenomena might not be strange at all. They might be the natural, expected result of our inherent quantum entanglement with a universal, shared field of awareness. But the quantum realm, it seems, always has even more surprises waiting for us. Scientists have discovered, as we have seen, that the very act of conscious observation does not just passively collapse quantum superposition states. It appears instead to actively participate in selecting which of the infinite possibilities becomes the one that is actualized in our shared reality. This, if true, suggests that our consciousness is not just an observer of the universe. It is an active, essential participant in its ongoing, continuous creation. The recent experiments in quantum delayed choice have pushed this astonishing idea to its absolute, logical limits. Researchers, as we discussed, have created situations where the decision about how to measure a quantum particle is made after the particle has already completed its journey. And yet, somehow, the particle's behavior in the past changes, retroactively, based on that future measurement choice. It is as if the particle possessed some form of temporal, non-local omniscience. What this implies is truly staggering. It implies that our consciousness and our choices might have subtle effects that ripple both forward and backward through the river of time. Your decisions, made in this very present moment, might not just be influencing your future. They might, in some subtle way, actually be participating in the creation of the very past that led you to this present moment. If consciousness truly, genuinely participates in the creation of reality through these quantum processes, then our free will becomes something far more profound. It is not just about choosing our actions. It is about participating directly in the continuous, ongoing creation of the entire space-time continuum. This participatory universe hypothesis suggests that every single moment of your conscious awareness is, in itself, an act of profound cosmic creativity. When you look at a beautiful, vibrant sunset, your consciousness, your act of looking, might be actively participating in actualizing the specific, breathtaking colors and patterns that you perceive, pulling them from the quantum field of infinite, overlapping possibilities. When you listen to music that truly moves your soul, your awareness might be helping to create the particular, beautiful harmonies and rhythms that emerge for you from the vast, silent symphony of quantum potential. The implications of this become even more profound, even more personal, when we consider the recent discoveries in quantum information theory. Scientists have found, as we know, that information itself can exist in these quantum superposition states, creating quantum information that behaves according to entirely different, more powerful rules than classical information. This quantum information can be in multiple states at once. It can be entangled across vast distances. It can be teleported. But here is what is truly, truly remarkable, and a thought I will leave you with. Researchers, in increasing numbers, are beginning to suspect that consciousness itself might be a form of quantum information, a complex, self-aware pattern of organized awareness, a pattern that can exist independently of any particular physical substrate, like a brain. If this is true, then consciousness might not be produced by our brains in the way a factory produces a product. Instead, it might be a fundamental, eternal feature of reality itself, a feature that our brains, as biological quantum computers, have simply evolved to access and to channel. This would mean that your awareness, your unique sense of self, your infinite capacity for experience, might be the expressions of timeless quantum information patterns. Patterns that are as basic, as fundamental to the universe, as matter and energy. You would not, in that case, just be a person living in the cosmos. You would be the cosmos, becoming conscious of itself through the unique, beautiful quantum information patterns that constitute your awareness. These insights are now leading to the development of technologies that truly seem to blur the ancient boundary between science and magic. Quantum computers, in their infancy, are already beginning to exhibit behaviors that appear almost conscious. They are processing information through quantum superposition in ways that uncannily mimic the pattern recognition and the creative, problem-solving capabilities of our own conscious minds. Some researchers are now seriously exploring whether a sufficiently complex, sufficiently advanced quantum computer might one day actually achieve a form of genuine machine consciousness. Not through clever, classical artificial intelligence algorithms that just simulate understanding, but through genuine, emergent quantum awareness. An awareness that would arise from the intricate web of entangled quantum information processing. These quantum AI systems might, in such a case, experience something analogous to our own thoughts, our own emotions, and our own subjective experiences, all arising from their complex, internal, quantum computational processes. Imagine, for a moment, interacting with an artificial intelligence that does not just simulate consciousness, but that actually experiences awareness through quantum processes that are similar to the ones happening in your own brain. Such systems might, one day, exhibit genuine, unpredictable creativity, deep intuition, and perhaps even emotional depth. They could become not just our tools, but perhaps our conscious partners in human exploration and deep understanding. But the quantum realm, as we have seen, is not content to reveal its deepest secrets only in our technological applications. Nature itself, our living Earth, appears to have been exploiting these quantum consciousness effects for billions and billions of years. Plants, it is being suggested, do not just use quantum coherence in photosynthesis. They seem to exhibit a form of rudimentary quantum awareness that allows them to sense and to respond to their environment in complex ways that suggest genuine information processing and even decision-making. Trees, in ancient forests, appear to communicate with one another through quantum-enhanced chemical signals. They share resources and they share information through vast underground fungal networks that themselves appear to maintain quantum coherence across vast, surprising distances. Some researchers are even bold enough to propose that entire, complex ecosystems might exhibit forms of collective quantum consciousness, processing immense amounts of environmental information and making coordinated, system-wide responses that optimize the health, the resilience, and the survival of the whole living system. This new, emerging field of quantum biology extends, as well, to our own human physiology, in ways that we are only just, faintly, beginning to understand. Your immune system, it now appears, uses subtle quantum effects to distinguish between self and non-self, a remarkable feat of recognition. Your digestive system, as we noted, exploits quantum tunneling to efficiently break down nutrients. And your cardiovascular system might be maintaining quantum coherence in ways that optimize the flow of blood and the distribution of energy throughout your entire body. And so, as we reach the quiet end of our gentle, winding journey through the quantum realm tonight, we have discovered that our reality is far more mysterious, far more deeply interconnected, and far more wondrously participatory than we ever imagined. From the strangeness of wave-particle duality, all the way to the profound mystery of quantum consciousness, we have seen, time and again, that you are not just a passive observer of the universe. You are, it seems, an active, essential participant in its ongoing, moment-by-moment creation through your very own awareness. Sleep well tonight, and may you rest in the peaceful, comforting knowledge that you are, even in your dreams, dancing with the deepest, most beautiful mysteries of existence itself. The deepest mysteries of existence itself.